Welcome back to Management Decision Tools. In this section on LP applications, we will focus our example discussion on operations management application. So what this means is in the sense of optimizing the arrangement of things, scheduling product mix, producing goods, factory operations, including staffing and inventory control, capacity planning, and in many other ways, everything, all the control parameters involved in operations. So one thing that we will pick up in this particular example is how we can uh, take care of certain situations that are kind of looking very different in real life, all right? And yet, when it comes to modeling, we can apply the same tricks. So reusing the same translation tricks in LP modeling. And also one important uh, modeling trick that we will pick up here in this example, and that is on taking care of ratiometric kind of constraints. Okay, so let's try to understand what this example is all about. Here we are going to produce wings. So the wings are basically aeroplane wings. So they are huge. They take time to produce, and the company has to produce 20 wings in the first month, April, 24, and 30 in the next 2 months. If that is all right, if that is it, then basically it's quite easy, right? Just make to order. If you have 20 to deliver this month and you don't have extra location to store to inventorize the wings, just make to order. So this month produce 20, the next month produce 24, and the third month produce 30, make to order. Finish. There's no way to optimize. But let's see what happens. It has workers, right? So you have 100 fully qualified workers, and we might wonder at this point what does fully qualified mean. So let's read on. So a fully qualified worker can either be in production or in training. Okay. So we're in this situation where we can grow, we can train new recruits. They are incoming workforce. A new recruit can be trained to be an apprentice in a month, 1 month, right? So now notice how this looks so different from the financial application example we discussed earlier on. Yet, if you think about it, if we rephrase it, it's saying that this recruit sounding like an investment option, right? This investment option takes 1 month to mature. This recruit takes 1 month to mature into the status called apprentice. And if you think about it this way, then as far as translation into LP model and constraints are concerned, they're the same, right? Because maturity in financial applications is basically changing or promotion, change of status in the operations situation or human resource situation, right? So for that matter, uh, they're the same when it comes to translation. So let's keep that in mind. Although it sounds like very new, our first discussion of promotion or a change of status after a training period, this is just like an investment maturing in a given duration, right? It's the same. And we know how to model time in LP model now, so we can reuse our tricks there. Nothing extremely new here, although the wordings are very different. The application domain is sounding very different, but from the LP modeling and translation perspective, same trick, right? After another month, that means for starting from as an apprentice, it takes another month for the apprentice to become a worker, at which point this qualified worker can either be deployed as production or as trainer. Each trainer can train at most two recruits. just to take care of the case that there are odd number of recruits, right? So each trainer can train up to 2 recruits because they're apprentice. The attention has to be there. So let's say the company policy says each trainer cannot take care of more than 2 recruits. Sounds reasonable, and it is this part that we will encounter some difficulty. So I will focus on this line in a while, but let's quickly scan through the rest. We are given production rate, salary, and we can imagine these will be the coefficients that we need to plug into. Just take one look, and it has to be constraints because it's probably constraint coefficients, right? Of course, it can also be numbers that we plug into objective function, but let's see what do we have to optimize. Don't assume, let's see what we need to do. In this case, for the month of June, NWC wishes to have no recruits. At the end of June, NWC must have at least 140 full-time workers. Now, notice how this sentence sounds like the financial application case where we say at the end of the 4-month planning horizon, we must have at least $10 million. Here it is at the end of the 3-month planning horizon, we must have at least 140 workers. Okay, fine, one is money, one is worker, but let's say amount of dollars and number quantity of workers, at least 10 million, at least 140. Same translation, right? So we can do the same thing. And it involves month. And when it involves months, we need to be careful of the quantity that we snapshot within the month. Is it at the end, the middle, the end, right? So again, we want to be extremely clear with our definition of the decision variables. At what point in time of the month are we counting? Yeah, because the numbers can change. So again, we default to using start of the month or start of the interval. So if it's week of planning, then we say at the start of the week or at the start of the year. So here we say at the start of the month. Now, we're given the production rates for each kind of workers. Production workers produce a lot, 0.6 of a wing per month, very very rapidly. Trainer half the rate, but trainer gets to train people, so we allow for half time. Trainer gets paid a lot more, and production 3,000, right? So apprentice turns out to be contributing more to the progress of wings production than trainer, so they are paid equally decently. And we need to get up to speed of for recruits because they contribute 0.05. Maybe they help to carry tools, maybe they buy lunch for the workers and therefore improve productivity of the workers somewhat. So they contribute in that sense, and they are paid a salary. Okay, now perhaps in this summary slide, it wasn't stated as in what is the concern of the problem owner. But of course, we should be able to guess, although it's not ideal, we shouldn't be guessing, but we can deduce that saving cost should be the prime objective of this company's operations. It is possible that we may also try to maximize, progress of the wings, or maximize the number of trainers for a certain month, or maximize certain number of production workers for a certain month. Although the real goal or reasons to have those objective functions might not be so clear. So for operations, typically it is to minimize overall costs. Okay, so let's see how we can do that. Clearly, we need to have 4 decision variables already: number of production workers, number of trainers, number of apprentices, number of recruits. The question is also, how many recruits do we hire, do we take in at the start of every month, remember, right? So we not only have to have 4 variables, because then we say, well, we have 3 months to think about, right? Every month we ask how many worker of each of the 4 types do we need. Okay, now of course the second month's for example production workers is not totally de-linked from the first month's, the previous month's production workers. The second month's apprentice is not completely detached from the previous month's recruit, yeah, because it takes 1 month to mature to get promoted to apprentice. So we need to link them together, but instead of using the subtractive way of saying things, given that the second month has 5 apprentice and you know 10 trainers and 10 production workers and a total of 30 workers, then we minus to get the number of recruits. We don't deduce the number per se, right? We don't subtract to get the results. Instead, we dedicate fresh decision variables to describe, right, each kind of unknowns that we have. And then when we need to describe the aggregate, for example, we ask total number of workers must be at least 140. Then we add up the aggregate variable, the individual component variables to come up with the aggregate total. So very quickly, we are going to basically flesh out 4 times 3 months, that is 12 decision variables, right? So let's take a look at the offered solution here. So indeed, we have 4 types of counts of different 4 kinds of workers for each of the months. That's the basic idea, basic thinking. But we know that, for example, at the start of the 3rd month, we will not be hiring, right? So in June, we will not be hiring. So one way is to say we have R3 for June and then constrain it, set R3 to be equal to 0, right? But that's sounding a little bit strange because we already know the outcome. We cannot optimize it. Company policy says R3 equals to 0. So we can say R3, define R3 and constrain it to be 0. But since we already know the outcome, we can just delete the variable. So there's no 3, right? R3 for June. If there is no R3 for June, then we also don't need trainers for June. So for that reason, we sort of optimize the model a little bit by saying that, okay, we already know by the logic of the company's policies, we need trainers to train recruits to become apprentice. If there are no recruits, we don't have to allocate trainers, right? Or we pretend we don't know how many trainers we need and then let model figure out that it should be 0. We don't need that, so we cancel out T3. Now, for first month, there should be no apprentice, all right, because we currently don't have any recruits. So when we hire recruits, they cannot be directly promoted to apprentice. So even if they're very experienced, very seasoned, they come in as recruits. Now, you wouldn't enjoy that if you are a seasoned college graduate who can be given exam credits to jump into university second year, right? So that's exemption, but they don't have exemptions. They all come in as recruits and they take 1 month to get promoted. So for the first month, we should count 0 apprentice, and therefore for the same reasoning, we don't need to have A1 and set it to equal to 0. Okay, and production workers, we need that, and we don't know the exact numbers, so we need 3 holders, 3 containers for production workers. So far, so good. Okay, and of course, let's check the definition of our decision variables. It's got the unit, not thousands of producers, but unit producers, so number of producers, right? And it's got duration. It's for 1 month. It's not for 1 week, 1 day.